Now let us see the uses of pyridine. The first use of pyridine is as a solvent. Pyridine is a weakly basic polar aprotic solvent. Let us try to prove each of these points. Weakly basic. The lone pair of electron on the nitrogen atom of the pyridine ring lies in the sp2 hybrid orbital, which is in a different plane from that of the plane in which the unhybridized pz orbital of each of the atoms of the pyridine lie. That is to say that the overlapping of these two orbitals is not possible. In other words, the electrons in the sp2 hybrid orbital are not or cannot take part in the delocalization or the aromaticity of the pyridine ring. In other words, the electrons in the sp2 hybrid orbital are available for donation, and that is what makes the pyridine ring basic. Not only, to be very specific, the pyridine ring is weakly basic. The reason for this again is that the electron lie in an orbital which has a greater proportion of s character. To be accurate, the sp2 hybrid orbital has 33.33% of s character. That would make the lobes broader and shorter, and that would make the electron come closer to the nucleus of nitrogen. A closer electron means that the electrons are more under the influence of the nucleus and are not readily available as was expected. That is, the pyridine is not as basic as we expect from it. It is weakly basic. Number 2, polar. Pyridine is a polar molecule. Pyridine has slightly polar bonds. This polarity is because of the difference of electronegativities of the atoms involved in the bond, which creates polarity, a slight polarity in each of the bonds of the pyridine ring, and overall the molecule of pyridine becomes slightly polar. The dipole moment here now becomes greater than 0. Third, pyridine is aprotic in nature. The term aprotic means capable of exhibiting hydrogen bonding. The pyridine ring has a nitrogen atom to which there is no hydrogen atom attached. Had there been an hydrogen atom, it would have exhibited hydrogen bonding. But because there is no hydrogen atom which is attached to the nitrogen atom, it could not show any kind of hydrogen bonding, and therefore the pyridine ring is aprotic. It's a solvent. Indisputably, pyridine is a solvent. It can stabilize and solvate the positive addendum of any reagent because it has got lone pair of electron to stabilize it and to solvate it. However, the counterpart negative addendum, it cannot solvate. That is, it can solvate cations but cannot solvate anions, and that would make the pyridine a mild solvent or a partial solvent. Let us now look into the utilization of pyridine as a solvent. Pyridine has often been used for its catalytic properties, and this catalytic properties is credited to the basicity that the pyridine ring has been endowed with. The basicity is due to the lone pair of electron that the nitrogen has. One of the examples in which the pyridine has been used for its catalytic purposes is the sulfonation of pyrrole and furon. Here, the lone pair of electron on the nitrogen atom of the pyridine ring attracts and forms a bond with the most vulnerable hydrogen atom of the ring, that is the hydrogen atom that neighbors the electronegative atom of nitrogen and oxygen. While it forms the bond with the nitrogen On the other end, what results here is a development of negative charge on the adjacent carbon atom. It is at this negatively charged carbon atom that the electrophile attacks at the second step. In the third step, the attached sulfonyl group in the pyrrole and the furan ring abstracts the hydrogen back from the pyridine to form respective products, which is 2-pyrrole sulfonic acid and 2-furan sulfonic acid. What is notable here is the restoration of pyridine. The role of pyridine here is to speeden up the reaction, take part in the reaction, but at the same time pyridine never forms a part of the product in this reaction. This places or positions pyridine as a catalyst. Yet another example where the pyridine ring has been used for its catalytic property is manifested in no even acyl condensation. In this reaction, the lone pair of electron on the nitrogen atom of the pyridine ring attracts and forms a bond with the hydrogen atom that is attached to the carboxyl group of the malonic acid. While it forms a bond with the hydrogen atom, it also speeds up the release of the carbon dioxide molecule, thus initiating the speedy formation of the product, which is alpha beta unsaturated acid. The byproduct formed in this reaction is OH minus. This OH minus now abstracts the hydrogen atom, which is attached to the nitrogen of the pyridine ring, forming H2O. On the other hand, it leads to the restoration of the pyridine ring. The reaction again reinforces the status of pyridine ring as a catalyst. Pyridine does not limit itself here. It also acts as an acid scavenging solvent. The term acid scavenger means collector of acids. An example in which the pyridine ring is used as an acid scavenger is the acylation of amine. Acylation of amine is a reversible reaction. A reversible reaction means that the concentration of the reactants and the concentration of product has reached a steady constant level at which they are at equilibrium with each other. For us, it only means that we get a low yield of our product, which is an alkyl or aryl acetamide depending upon the reactant that we use. To increase the yield of the product, what we need to do is to remove the byproduct. If we remove the byproduct, the reaction would propel forward as per the Lee-Chatterley's principle. This is where we use pyridine. When we use pyridine, the lone pair of electron on the nitrogen atom of the pyridine ring attracts and forms a bond with the hydrogen atom of HCl. Because the nitrogen atom lost its pair of electron to hydrogen, it develops a positive charge. It is this positive charge on the nitrogen atom which now attracts the Cl minus ion towards itself, forming an ionic bond and thus resulting in the formation of a salt, which is pyridinium hydrochloride. To sum up, what has happened here is that the pyridine has collected the acid or consumed the acid in its cells, leading to the elimination of the byproduct and propelling the reaction forward, thus increasing the yield of our product. Another example which proves that pyridine is an acid scavenger is the elimination reaction that is involved in the conversion of alcohol to alkenes. In this reaction too, pyridine collects acid and forms pyridinium hydrochloride. Although the pyridinium hydrochloride and the collection of this acid has no impact in the rate of the reaction or the yield of the product, but it is noteworthy that pyridine, the use of pyridine determines the stereochemistry of the product. It determines where the double bond would come. When we use pyridine, what we get as the major product is the anti-Zaitsev product or the lesser substituted alkene. This, however, is of no relevance to the current topic. What we need to note is the consumption of acid by the pyridine ring once again, thus positioning pyridine again as an acid scavenger. Use number 2. Pyridine in denaturated ethanol. A denaturated ethanol is ethanol to which toxic additives have been added. Toxic additives are added to ethanol so as to make it unfit for consumption, so that the employees and workers working in an organization do not consume alcohol, and that the same alcohol can be used feasibly for industrial and laboratorial purposes. To speak in broad terms, different additives have different purposes to play in a denaturated ethanol. But to be specific on pyridine, pyridine is responsible for a nauseating odor in denaturated ethanol. The nauseating odor produced by pyridine acts as a repellent for consumption and signals the human brain that the consumption of such an alcohol would be lethal. Use number 3. Pyridine forms the main moiety and is used in the synthesis of the weedicide paraquat and diaquat. Both paraquat dichloride and diaquat dibromide are used in the control and management of weeds. Use number 4. Pyridine is used as an ingredient in mouthwashes. Cetyl pyridinium chloride, a molecule which has got pyridine as the main moiety, is used as ingredient in mouthwashes. This is used because it is known for its antiseptic property. Cetyl pyridinium chloride is known to prevent dental plaques and is used in the management of gingivitis. Gingivitis is the inflammation of gums. Use number 5. Medicinal applications of pyridine. Pyridine is the main moiety and is used in the synthesis of a number of drugs. Videlicet, the isoniazid and ethionamide. The pyridine ring in both these medicinal compounds have been demarcated, and both of these drugs are known for its anti-tubercular activity. Omeprazole, pantoprazole and rabeprazole. All of these drugs contain pyridine as the main nucleus, which has been demarcated in the structures of these molecules. These drugs are proton pump inhibitors and therefore possess anti-ulcer activity. Sulfapyridine and sulfasalazine. Both sulfapyridine and sulfasalazine contains the pyridine ring, which has been demarcated in the drug molecule. Sulfapyridine is used for Durhing's disease or dermatitis herpetiformis. This is a condition that is developed in individuals who have gluten sensitivity. When such individuals consume gluten containing food, which is a common protein found in maize, wheat and barley, they develop red, patchy and itchy skin. This condition is called as dermatitis herpetiformis, and sulfapyridine is used in the management of such condition. While on the other hand, sulfasalazine produces a protective layer around the ulcer, giving it anti-ulcerative properties. Therefore, it is used in ulcerative conditions of the body such as ulcerative colitis, Crohn's disease and inflammatory bowel disease. Pyridostigmine. The nucleus of pyridine has been demarcated in the structure of pyridostigmine. Pyridostigmine is an anti-acetylcholinesterase inhibitor, making it an indirectly acting cholinergic agent. This makes it useful for weakness of the muscle in our body, a condition referred to as the myasthenia gravis. Dear students, I hope you have liked this video and have found it useful. If it was useful for you, please do not forget to share this video with your friends. Subscribing the channel would help you stay updated on various topics of chemistry. Thank you very much.